Dear friends, today we are going to explain how we can create a truss in Autocad and then this created truss will be imported in Staad. Normally, trusses are used in godowns whose spans are large. Here we have taken an example of sugar godown of size 34 meter by 100 meter by 8 meter. Here 8 meter is the height of the godown. So for creating a truss, we should have some basic knowledge of the truss. Normally, center to center spacing of trusses are kept in between 4.5 meter to 6 meter, 6.5 meter, and this height of truss is kept between 1 by 6 to 1 by 12th span of the truss. By the truss height means the height of the peak of the truss from the bottom card. So center to center spacing of truss and then height of truss and then another very important point is the spacing of purlin on the top card. Spacing of purlins is decided on the basis of seat length available. Normally, seats are 3 to 4 feet wide and span varies from 8 feet to 12 feet. So spacing of this purlin is decided on the basis of seat length available for the roofing. In most of the cases, we use 10 feet length seat, and when we place the seat over purlin at the end, a minimum overlap between the two seats should be 150 mm to avoid the leakage. It is the minimum 150 mm. So depending upon the length of the seats and minimum length, we decide the spacing of the purlin. Here, suppose we are having 10 feet seat and 10 feet means it is 3.05 meter or 3050 mm. For this case, we keep spacing of purlins 1425 mm. Why? Because suppose it is a purlin and then we give a offset of this 1425 mm here, here. So this is quite large purlin. So we are making this very small. So it is a purlin. It may be of circular shape. It may be of angle. It may be of rectangular shape. Whatever may be the shape. My purpose is to show how we decide the spacing of purlin because it is very important. Center to center spacing of truss, we decide from the length of the go down. Type of the truss, we decide from the span of the truss. But spacing of the purlin is decided on the basis of seat length available. So it is this dimension is 2850 and we have removed this. Now we are placing a seat and as I have told that normally we use 10 feet length seat. So 10 feet means 3050 mm length seat. It is 2850. Now make it is 100 and here also 100. So this is the complete length 10 feet length seat. So when we put next seat here from here by overlapping this 100 mm here, it will be also 3050. So similarly here we will put a seat by overlapping this 100 mm. like this 3050. So this overlap is 200 mm. This overlap is 200 mm, 200 mm, and every seat is up 10 feet, means 3050. That means we are achieving minimum overlapping between the seat. So by this way we decide the spacing of purlin. This is very important in making the truss. Now I think uh, I have cleared how we decide the spacing of purlin. Now we are going to delete this. Now we are going to create a truss of this form. This form. We are going to create a truss of this form. For large span truss, we give a camber to the bottom card so that if there be any nominal sag, because large span uh, trusses sag, so we give a camber in bottom card. But in modeling it is not required to model this camber, and this height of the truss, this is called the height of the truss, is kept between 1 by 6 to 1 by 12 of the span of this truss. Here it is 34 meters, so it may be 34 by 6 to 34 by 12. But shallow means whose depth are less. Shallow trusses, that is, whose depth are less, have maximum force in their members. And one more thing I want to clear, in trusses, members have only axial tension and compression forces. There is no bending. So this is what about little bit about the basics of truss. So we are going to model such type of truss as I have earlier told that we export DXF file, not DWG file. So first of all, we will create a DXF file. But before creating a DXF file, we have to make a DWG file of the required truss. So as this drawing is having a different layer, we will not use any existing layer. We will insert a new layer for making the line diagram of truss. So insert a new layer, we can give any name to this layer as per our desire. So we are giving it as style. Instead, and we can give the desired color. We are giving this a yellow color. This. Now we will make this inserted layer as current layer. Now it has become the current layer. Now whatever we will draw, it will be drawn in this current layer. So as span of the truss is 34 meter, so we will draw a 34-meter line. Since this drawing is made in mm, so we'll take all the dimension in mm. So this is 34 meter. We will measure, this is 34 meter. Now as we have already told you that height of this truss will be kept as 1/6 of 34 meter. 34 meter by 6. It is coming 5,666.666. So we will make this 5675. 5675. 5675. Now we will join this point, now to this point. Now as we have to create a truss of such shape, this is the spacing of purlin. These are the purlins. So here we are taking the spacing of purlin as 1425 mm. As I have explained, this is the best spacing for the 10 feet length sheet. So now we will mark a perpendicular point here. Now copy this at this location, and give a offset of 14 to 5 like this. This, 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 this. Now it is over. Offset 1425 because it has been deleted by mistake. Now draw the vertical line from here. Now join the point. Now join this midpoint. Now join this point. Now join every alternate point, every alternate point, every alternate point. Now join this point like this. This, 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 this. So when you will go through in details of the shapes of the truss, you will be able to know why this this shape has been taken, because this shape is suitable for 34-meter span. So depending upon the span, if you go in detail of trusses, you will be able to select the shape of the truss. So this is the suitable shape for this 34-meter span truss. Now we can here copy all the members, mirror all the members about this. Now our truss is ready. As we know, the height of this go down, as I have earlier told, it was 8 meter. So we will draw a 8000 mm line here. 8000 mm line here. Copy this line and paste here. So now we are ready with the truss formed in new inserted layer. We are not using any existing layer earlier in the drawing. Now since this drawing is in mm, and I have told in my previous video that instead we normally give inputs in meter and kilonewton, that is in SI system. So as the when we export the data, only digits are exported. So if we export this directly by making the Excel file, it will be there 34,000 meter in our stack. So we will reduce this by reducing it by 0.001. So 0.001. Now this drawing has been scaled down by 0.001. saved. Now copy this by edit command, and now open new Autocad file, format this for unit as it is here in millimeters, make this in meter. Okay. Now check it for dimension style also. Modify it is a decimal, for meter it should be decimal, factor should be 1. Okay. Close. Now paste uh, earlier copied truss drawing by edit command here. It has been pasted here. Here we are seeing that this drawing has been pasted here with the inserted layer. Now we prefer to have here only one layer. So keep this image in 0 layer. Okay. Now use purge command, purge, purge, purge all items. Actually, we do this purge so that here should not be any unwanted layer copied from our original drawing. Now, as we do not know for this drawing where is 0 0, so we will preferably we want when this drawing be exported in stat, our 0 0 should be here. So we will copy, we will move this point at 0 0 location, 0 comma 0 comma 0. Now as the drawing is not on the screen, so Z enter A enter. Now we are seeing that our column base has been kept at 0 0. Okay. Now since we have opened new AutoCAD file, yet we have not saved it, so we are going to save it. So file, save as, where should be, where it should be saved? It should be saved in our example folder, which is at our desktop. Example folder, where is it, our example folder? Yeah, this is example folder, and we will give a suitable name. Suppose we are giving it as a truss. Truss. Save it. Now this drawing has been saved in DWG format. Now once again we will save this file as in DXF format. Save. Now our new drawing has been saved in DXF format. Now we are going to close this. Now we will see our example folder. Here we are having the truss drawing in DXF format. Now close this. Now we will open our Staadpro. Then new project, next, finish, half the grid. Now file, and we will import our created DX 3D XF. Import. It was at the desktop in example folder. So we will go to desktop, then we will in our example folder CD. Yeah, this is. Now this is the DXF created. Now here it is very important. When we will export our plan, 2D plan, our building plan, we keep this Y up. But here we are not going to make any changes, because if we will keep this Y up, our truss will be exported in plan, not in elevation. So like exporting building plan, we keep this Y up. Here we will not keep this Y up, we will kept on this no change. Okay, and now unit should be meter and kilonewton. So then it is okay. Now we see that our truss has been exported correctly. Now we can check the dimension. It is 34 meter, and this is 8 meter. Okay. Now we will on this tools, check multiple structure. It is one structure, single structure, close. But we will see that member meeting with each other are not intersected. In our stat, every member should be intersected by a joint, or should be connected by a joint at the junction. So we will create the joints between the members. So select this. Now go to the geometry, then go to the intersect selected members, then intersect. Now we will see that everywhere there is joint, everywhere there is joint, joint, joint. Now we can assign support to selected, create fix support and assign. We have assigned the support. Now we will see the coordinates of this point. It is 0, 0, 0. Now here in tools we will check for duplicate nodes, no duplicate nodes. We will check for duplicate members, no duplicate members. We will check for orphan nodes, no orphan node, and we will check for zero length member, no zero length member. We will check for overlapping members, no overlapping members. Now we will open this editor. Now as we are going to open this editor, it is asking to save it a suitable name file. Now we are giving it this Truss. Now here editor has been opened and we are seeing there is no any zero with the negative sign or any coordinates with the factor e to the power minus any number. So everything is okay. Now we can copy this to a center spacing of trusses were 5 meter. So we will copy and paste this at z is equal to 5 meter. 5 meter. There is something wrong. We will undo this. Okay. Now copy, paste y at z is equal to in this direction. So 5 meter. Now it has been copied at 5 meter. Now we will join this for purlins. Now we'll add this plan and now we can mirror these members. We can mirror these members. Plan. We can mirror these members. Make this. Mirror these members. Mirror. Mirror about notice this. Okay. Now as it is 100-meter span, 100 meter, so it can be repeated for 19 times. So translate in global z direction, spacing is 5 meter, kept is here is 19. Okay, okay, okay. Now we can measure here, it is 100 meter. So we have created our truss. So this is what I want to explain in this video. In my view, creating a very correct geometry is very important. Everything depends on the geometry created. Once the geometry is created perfectly, all further work needed to complete the modeling is a mechanical process, is not very tedious process. So we always emphasize to create a very perfect model. After creating the model, our most of the uh, time taking work is over of modeling. Now I am finishing this video here and hope for your comment. Thank you.